Good day, everyone, and welcome to the Touch Panel Capability, Design, and Assembly webinar. My name is John Stabers. I'm the Vice President of Sales here at Epic Engineered Technologies. As many of you know, Epic is in its 60th year as a designer and manufacturer of build-to-print electronics. Today, our presenter is Derek Dixon, the product manager for user interface products here at Epic. Derek has been exclusively involved with user interface products for over 15 years. Today, Derek spends the majority of his time working with our customers, helping them with their interface designs to make them more reliable, cost-effective, and manufacturable. Our objective today is to provide you with information that will aid you in working with touch panel technology. But before I turn it over to Derek, I want to go over several technical items. First, if you have any questions, there's a spot at the bottom of the control panel that will allow you to type in any questions you might have. As time permits, at the conclusion of the presentation, Derek will attempt to answer as many of those questions as possible. Secondly, we are recording this webinar, and we will post it on our website along with any questions and answers we don't get to today. Once it's posted within the next few days, you'll receive an email with a link to that posting for your use and future reference. Lastly, we will continue to host webinars such as this every other month, using it as a primary mechanism to provide more technical information to our customer base. So without further ado, I'll turn it over to Derek.
Thank you, John. Good afternoon, everybody, and thank you for taking the time to join us on the Epic Touch Panel webinar. As John mentioned, I have over 16 years experience with user interfaces. About 16 years ago, when I was initially introduced to touchscreens, there was one technology that dominated the commercial market, and that was resistive touchscreens. Most people remember the first generation PDAs from Palm and Apple that used a stylus. Well, these products all use resistive touch panels. Today, there are approximately 20 different technologies available for touch panels. Yet with all the technologies and innovations that we've seen, there still isn't one perfect touch technology. Each technology comes with its pros and cons. Epic offers proven technologies that address the vast majority of applications and sizes used in today's marketplace. Today I'm going to review the touch products we offer, discuss design parameters for products incorporating touch, and review the integration of the touch panel with an LCD and a bezel. One second there. So as we all know, in all the products we're using, touch panels have become the user interface standard today. The most common touch panel is a resistive touchscreen. It's the workhorse of the industry. In 2012, resistive touch panels accounted for approximately 26% of the market. How resistive touch panels work is fairly simple. You've got two layers of conductive materials that are separated by a dielectric. You'll hear people refer to this as spacer dots. Pressure on the top layer is going to bring the top layer in contact with the bottom layer. The controller is going to detect this, and a touch point is going to be calculated. There are three different types of touch panels. Each works in the same principle, pressure bringing two conductive layers together. The first is 4-wire. The construction of a 4-wire is such that there are actually two separate layers. One layer carries the X, the second layer carries the Y. Touching them brings these together, and the touch is going to be calculated. The biggest disadvantage of this touch screen is that if the top layer is damaged because it carries the X coordinates, the touch screen is no longer in use. If it's scratched or ripped, it's not going to function. So it's going to need to be replaced. The second is a 5-wire touch panel. With a 5-wire, we've got a film that's suspended over the top layer that voltage is applied to each corner of the touchscreen. And when the user presses the top surface and brings it in contact with the bottom, they're going to change the resistance, and that's going to be calculated using the controller. The benefit to this touch layer is if the top layer is damaged, scratched, torn, because the top layer is only acting as a probe, it's still going to activate. So it's a more durable design. Third resistive touch technology is an 8-wire. Now, an 8-wire is based on a 4-wire technology principle. So we've got 4 wires, but what we do then is we actually add 4 additional wires to each electrode, giving us a total of 8. The benefit to this is because we have double the number of electrodes, it's going to have better accuracy, and we're going to reduce drift. So you're not going to have to recalibrate the touch panel as much as you would a 4 or 5-wire touch panel. Now, usually with these touch panels, they're in larger size, used in larger size displays. So usually about 10 inches is up is where you're going to see the 8-wire touch panel used. Again, the benefits in general with resistive is it's a low-cost technology. It's been around a long time. It's a proven technology, but it's a low-cost technology. Low power consumption. And it also is going to activate virtually using anything. So a finger, a stylus, even a gloved hand, because it's relying on pressure, is going to activate a resistive touch panel. It's resistant to water and dust. So if it's going to be used in an outdoor application, or it's going to be used maybe in a machine shop where filings, things are going to come in contact with the touch panel, it's not going to create a false actuation. They do have their limitation. One limitation is one touch. In today's society, we're all used to multi-touch touch screens. This is one touch. Now, I'm going to put a little asterisk next to this because there are some controller companies that are working on doing multi-touch resistive touch panels. So it is out there, but it isn't the norm or the standard. One touch is the standard. They have relatively low light transmission, on average about 80%. So if really crisp, clear graphics are important, a resistive touch panel probably is not the technology you want to use. And low durability, because resistive touch panels are using ITO film as a conductive material. And ITO film is relatively brittle. Repeated flexing and pushing is going to actually create little tiny cracks. And that's one of the things that degrades the touch panel's ability to operate. So for a 4-wire touch panel, we're able to get 1 million actuations in one location. A 5-wire, because we've got the probe, it actually will last up to about 10 million actuations. An 8-wire, although it's drift-free and we don't have to recalibrate, because it's based on a 4-wire, we still have the same issue with cracking and fracturing of the ITO film layer, so we're back to 1 million actuations or 1 million touches. Size range in all of these is 2.8 to 21 inches, and with EPIC we've got standard sizes, but we can also do custom sizes depending on your application. The next technology that we offer is infrared. And infrared works on infrared LEDs and sensors that are placed on the perimeter of the bezel. And so a light beam is shot across from the LED to the sensor. Anything that disrupts that light beam, so an opaque object, a finger, a stylus, that breaks that light beam or reduces the light going to the sensor is going to register a touch. So the controller is going to sense that, calculate where the touch was made, and that's how that one operates. The benefits to the infrared touch panels are they're really good. It's a good technology for large size screens. They do have the ability to do multi-touch, 2 points. And again, it's going to work with any opaque object, so a finger, a stylus, anything that's going to disrupt that light getting to the sensor is going to register a touch. Because we're not flexing the film like we do in a resistive, it's very high in its durability, number of touches. And there's no glass substrate. So the light transmission is excellent. We don't have to have an extra piece of glass or film over the top to degrade the light coming from the LCD, so they're very clear. Now, they do have a few limitations. Number one is the profile height. Where we have the sensors and LEDs, they've got a certain height to them. So the bezel height is going to be higher than you're going to see in other technologies. They can be affected by bright lights, especially sunlight. So the usage for these is generally going to be indoor. But again, a benefit or sometimes a limitation is it's going to need a finger or a conductive stylus or anything that's opaque to operate the touch pen. Size range, these again are being used in mostly large applications, so we're talking 15 inches to 46 inches. And we do offer standard sizes, and we can offer custom sizes. The next technology is surface capacitance. So what this is measuring is current. So we've got film that's, again, put over the top surface. Voltage is going to be applied to the corners. When a finger or a conductive stylus comes closer in contact with the top surface, we're changing the current. The controller is going to register that change and locate the touch point. The big market for these, where these were used a lot and they still are, is going to be the gaming industry. So you've got fairly large screens, and they want bright, clear, crisp graphics. The technology has great light transmission, about 90% or above. It's not affected by moisture, temperature, or dust. And it's going to work with a finger. So, you know, if it's a cold weather application where the user may be using gloves or things like that, it's not the technology. It's going to need a finger or a conductive stylus. But because we're not flexing material, again, we're going to get a good number of actuations. It's going to be very durable. We're up to 100 million actuations on the surface capacitor. Limitations are single touch. So again, if you need multi-touch where you can expand photographs, images, things like that, it's not the technology. What can be a pro sometimes can be a con, and that's it's going to need to use a finger or conductive stylus. It may require calibration, and it's due to interference that may be around the screen or below the screen, the LCD. The EMI may require some calibration. Size ranges are 5 inches up to about 24 inches, and again, we offer standard and custom sizes in this technology as well. Projective capacitive technology is it is the glamour product of the industry now. Thanks to the iPad, the iPhone, and some of the Android-based phones, this is the dominant technology right now, and it's going to continue to grow. In 2012, projected capacitive accounted for about 64% of the marketplace. And really how this works is there are two parallel layers of materials, of ITO, conductive material, that form a grid of capacitors. An electronic field is projected through the top layer of the glass. So there's energy that's being sent to these. It's going to have a capacitive or electrostatic field. When a finger comes close to the top of the surface or touches the surface, the change in capacitance is going to be detected, and that's going to calculate where the touch point was made. And like I said, this is really the product that's driving the industry right now. The benefits to this are the top layer is generally going to be glass, and the glass is going to be scratch resistant, a very durable glass. And we can do multi-touch. So with projected capacitor, we're talking 2 to 10 touches at once, simultaneous touches and recognition of that touch point. Touch coordinates are drift-free. It's the projected capacitive is always scanning the XY coordinates, so it's not going to have any issues with drift. It doesn't need to be recalibrated. And the clarity is excellent. So again, we're talking about 90% light transmission on this type of technology, which is why you've got the iPad and the iPhone with just incredible graphics with the LCD. And with this design, we can use a zero bezel design. And what I mean by that is that top layer can be flush all the way to the edge. So you don't have a plastic or some kind of housing over the edges of this. So it's really clean and really fine, aesthetically pleasing bezel design. There are a couple limitations. Right now, gloved hands can be a limitation. I put an asterisk because depending on the type of glove and the sensitivity that is programmed using the controller, you'll see it used in some medical applications where nitrile gloves, some latex type gloves, some thin gloves with no seam can work with some projected capacitive. But if it's a cold weather glove or the glove does have a seam that's going to act as an insulator, it's not going to work. And it does have some higher cost points. Now the cost is coming down as more and more people are using projected capacitives. So it's being used more and more, which, like anything, it starts in the high end and it starts to trickle down to other industries. So the quantities aren't quite as high that are needed for projected capacitive. And just with the pure volumes being manufactured, pricing is coming down. Right now, it's available in 7 to 24 inch. The most common being 7 and 10.1. And again, these are measured on a diagonal. The controls and interfaces, every touch panel is going to need a controller and some kind of interface. And what the controller is it acts as a translator. So when somebody touches the top surface of the touch panel, the data information needs to be sent to the controller that's then going to convert that to a language read by the drivers. The interface is really just a communication interface. So it's how the touch panel is going to be connected to the motherboard or the computer. And drivers available, we work with the Windows, so 7, 8, XP. We work with Linux and also Android drivers or operating systems. So I get this question a lot where folks will come and say, what's the best product what's the best touch technology for my product? It's a tough one to answer in general because we just touched on some of the most common and some of the technology that we offer, but there's a lot of technologies, and even just with our technologies, it's a tough one to answer. So I ask a couple of general questions to get started. Number one, what's the size of your touch screen, your LCD? Number two is the environment. Where is it going to be used? And then I ask what the application is going to be. I like to get a sense of where it's going to be used. Is it going to be a medical product, military? For example, the photograph we have here is a military GPS. They're going to have certainly different requirements than a product that's going to be used in a house, some kind of household appliance. So knowing the application helps a lot to start narrowing down what touch technology will be used. Durability issues. How many number of touches are you going to need to get out of your product? Surface hardness. Again, a good example is this GPS. They may, because it's going to be a rugged GPS, they may need the surface hardness to be something like Gorilla Glass or a very hard, durable surface as opposed to what our general spec is for surface hardness. And knowing that we can spec that in. How it needs to be sealed. If it's going to be exposed to water or outdoor applications, we may need to seal it to meet a NEMA 4 and IP65 requirement. And then the type, how it's going to be, how the user is going to activate the screen. I'm not going to recommend a projected capacitive if it's going to be used out in cold weather, and the person may have winter gloves on. And lastly, cost. If it's going to be a toy or a low-cost product, I'm certainly not going to recommend a higher cost technology. I'm going to think, that resistive, some type of resistive, may be the answer to the application. But those are some of the design considerations that I work with our customers. Touch panel integration. There's really two ways to integrate. You're either going to integrate from the rear, or we're going to integrate it from the front. And again, I can work with, and our engineering department can work to specify what's going to be the best for your solution and your application. Here are just some general guidelines. There's a lot more available that we can help you on, but here's some general guidelines when you're looking to integrate a touch panel to a bezel and LCD. Now, as I said, there are a number of additional design requirements to consider, and myself or my engineering team can help you and assist as far as the integration and make sure it's done properly. There's a whole list of questions we're going to ask and detail that we can get into, but we can help you when the time comes on that integration. Here is a chart, and this kind of goes along to there's no perfect touch panel technology. There's a variety of ways to address the touch technology. This kind of gives you just sort of a quick snapshot of what's out there and some of the things to think about or consider when you're thinking of different technologies. It's really just important to understand that the different technologies in order to find the best one that's going to be suited for your job. And that's part of what my job is, as John had described earlier, is I work with you to try to identify or help you identify the best solution for your application. And to summarize, we have a wide variety of touch technology, touch solutions. And we can work with you to figure out what's going to be the best one for you. We've got standard sizes as well as custom sizes available. And we've got a complete engineering and design team. So, for instance, if you come and you need help on maybe reverse engineering a project, we can certainly work with you and on that application. And here is just a list of other products, build-to-print products that we offer. I'm sure most of you are probably well aware of our product offerings. We offer complete custom build-to-print electronics. So custom battery packs, flex and rigid flex circuits, graphic overlays, membrane switches, and fans and motors. If you have any questions or would like some other information on any of these products, you can visit our website, or we've got some contact information here, and you can contact us at engineering or sales, and we will certainly work with you and get you the information you need. A couple of questions came through while I was on. One of the questions that get sent in is, can you manufacture drop-in replacement for discontinued touch panels? We actually have worked with several customers where they've come to us and say, hey, you know, my current vendor discontinued this touch panel, tail location changed, or something changed that I can't use it, what they're offering me, because it's going to cost me too much to reconfigure my device. Can you reverse engineer something and build it for us? And the answer is yes. And like I said, we've done that with several customers. So if you do have something in particular, certainly contact your salesperson or myself, and we can take a look at it and we'll work with you on that redesign or reverse engineering. One other question real quick. They asked, can you provide standard sizes available for 4-wire touch panels? We can. I will see who sent that in, and we can email you or make it available on the website along with this webinar, a full list of our 4-wire, standard size 4-wire touch panels as well as 5-wire touch panels. So that will be on our website. We can email you that answer. So that's really about the time I have. I don't want to take up too much time on a Friday afternoon. If I wasn't able to get to your question, I will review the questions and I'll reply back an email, and we'll actually post the answers on our website as well. But if you have any questions, feel free to contact myself. You can use the sales at Epic Engineered, or you can contact your local salesperson, and they'll get back to me and we'll follow up with you. Thank you for taking your time to join us in the webinar. And like I said, if you have any questions, feel free to contact us.